Welcome to the Introduction to FEMAP video series. In the previous video, we started the simulation process on a machined ARM component and imported and cleaned up the CAD data. In this video, we'll continue the simulation process and define materials, element properties, and boundary conditions to the model. With solid finite elements, the three dimensions of the element with the material definitions implicitly define the element stiffness and mass properties. However, with the two-dimensional plate and one-dimensional beam elements, further element properties must be defined, such as plate thicknesses and beam cross-sectional dimensions, etc. The property hierarchy is such that the elements refer to element properties, which in turn refer to material properties, so we have to define both element and material properties. So first of all, we'll create the material data, aluminum alloy in this case. To create a material, expand the model tree in FEMAP's Model Info pane and right-click on the material object. From the context-sensitive menu, select New. Note that in the Define Material dialog box, you can change the material type from the default isotropic to one of the many material types supported by FEMAP. For this model, we'll select an aluminum alloy from the extensive metal alloy material database included with FEMAP. Selecting the material in the Model Info pane sends the material data to the Entity Info pane for reviewing and editing if needed. To create an element property, right-click on the property object in the Model Info pane and select New. To change the property type to a solid from the default plate element type, click the Element Property Type button in the Define Property Type dialog box and set the element type to solid in the Element Property Type dialog. Select the material that we defined previously for the solid element property and supply a descriptive title to complete the property creation. Next, we'll define the loads and constraints, which can either be applied to geometry or directly to a finite element mesh in FEMAP. FEMAP manages different boundary conditions through the use of load and constraint sets, which can be combined and, for loads, can also be scaled. To create a load set, right-click on the Loads object and select New. Enter a descriptive name for the load and click OK. Expand both the loads and the newly created load set objects. Right-click Load Definitions and select On Surface from the menu. Note that you can select through the part to select the surfaces that the load is to be applied to. You can select the Preview button in the Entity Selection dialog box to highlight and check what you've selected before clicking OK. In the Create Loads on Surface dialog, add a title and change the load type to bearing force. Enter a value for the bearing load, which in this case is 500. Deselecting the Normal to Surface option changes the load from radial to directional. After clicking OK, we'll define the direction of the bearing load. To change the vector direction from the default start and end of the vector, click the Methods button and select Components. In this case, the base of the vector will be the center of one of the arcs on the hole at the top of the arm. Clicking the Preview button will generate a temporary display of the vector, using the values in the dialog box. The dx, dy, and dz components we want are 0.5, minus 0.25, and minus 1 respectively. By expanding the Load Definitions object and selecting a load, we can check that the load application is correct. We'll now apply a pin constraint on the holes at the bottom of the arm. Just as we did to create a load set, right-click on the Constraints object and select New. After entering a descriptive name for the constraint set, click OK to complete set creation. Expand both the constraints and the newly created constraint set objects in the tree. Right-click Constraint Definitions and select On Surface from the menu. Then select the four surfaces that comprise the two holes at the bottom of the part. In the Create Constraints on Geometry dialog, change the type to Pinned before clicking OK. Selecting the constraint in the Model Info pane, you can highlight the geometry and check the constraint definition. In the next video, we'll move on and mesh the geometry to create the finite element model. Then set up the analysis parameters and output requests for the NX-Nastran solver. Don't forget that in FEMAP's help system you have access to a number of worked examples that you can step through, and there is a link to the FEMAP community, where you can network with other FEMAP users and post questions. There are also numerous other videos available that demonstrate FEMAP's capabilities, and these are available on the FEMAP website under FEMAP videos. To reach this page, and for further information about FEMAP, visit siemens.com/plm/FEMAP.